Welcome. We're going to talk about communication protocols for Industry 4.0. And as always, the lecture is available here if you want to download the PowerPoint and watch the lecture in case you missed something. Tonight, what we're going to talk about is what is Industry 4.0? What is a communications bus? What is the RS-232 standard? What is the TCP/IP protocol? What is the advantage of connecting using a USB port? And what is meant by asynchronous serial communication? So you might know some of this already, but let's start and take a look here and review Industry 4.0. So Industry 4.0 utilizes Ethernet connections to network manufacturing technologies. That's the IT-OT convergence. Now, this is where we're having a little bit of a problem in the world today because we've got a lot of people who know about IT, all the switches and wiring and everything like that, setting that up. And we got a lot of people that know about OT, operational technology, which would be robots and PLCs and sensors. But now that everything is going to Ethernet, it's hard to get people that know about both of these things, okay? So examples of Industry 4.0 include robots, smart sensors, program controllers, CNC machines, human-machine interfaces, and that's kind of what some of the stuff that's shown around here is here's my system integration, my robots. And so these are all part of a network. And so once you get an item on the network, well, then you can pump it up to the web and anybody in the world can take a look at it and you can modify it and see how things are going and make your company better. All right. So that's what Industry 4.0 is. All right. So PLC components are connected to the Ethernet. That is the goal. All right. So if I come over here, what I have here is a programmable logic controller and some miscellaneous equipment. Okay. And so up here I have a programmable logic controller, and what I've got right here is an Ethernet cable, and this thing is plugged into my computer. So whatever this thing is reading right here, I am connected here, and my computer is talking to this PLC right here. Okay. And if I wanted to connect some other things, right here I have digital I/O, and so I want to convert digital I/O, which is on or off, into Ethernet, which is what this does, and I can plug it in here, and then boom, all of my sensors and everything are connected into my PLC, which is connected to my computer, which can be connected into the world. I've got a lot of other things out here. Here's a legacy drive. This right here is a servo drive. Okay, and what this does is this connects up using kind of an obsolete, still out there, but not popular network called DeviceNet. Okay, well the issue with DeviceNet is it doesn't have an Ethernet cable on it. Okay, and so what you want to do is you'll take your legacy equipment and you'll run it through a bus, or you'll get a card or something like that, and then that would plug into here, and then right away. Now my servo drive controller is in my controller, which is into the Ethernet, which is pumped into the rest of the world. And so you get the idea there. That is how the Industry 4.0 is going to use the internet to make things better. Now, Industry 4.0 uses asynchronous serial communications, and it utilizes binary words. So let's just review real quick what binary is. It's important to remember that the brains of a computer are CPU. So all those items I just showed you, the drive and the PLC and the Ethernet I/O, well, those have CPUs in them, okay? And they all talk to each other, and they're all talking to my computer, and my computer's talking to the World Wide Web. So the CPU is composed of billions, millions or billions, depending on how advanced you got, of electronic gates. And electronic gates use the concept of the binary state, which is zeros or ones, off and on. So these zeros and ones come into gates, they're processed, and they return a 0 or a 1, and then they go into more gates and get processed, and pretty soon you got a computer examining millions of combinations of these zeros and ones and producing something useful. Maybe on this computer here I type A, and the computer doesn't understand what A is or B. A is converted to zeros and ones, and then zeros and ones get processed to the screen, and pretty soon when I type A, I get an A on the screen right here, okay? And when these items talk, they talk using binary words. So we talk using words, and our alphabet has 26 letters in it. Binary words, we're talking about 0 or 1, okay? So a 16-bit word or register might be 8 zeros and ones here, 8 zeros and ones here. Seems kind of simple compared to our alphabet that has 26 letters, and some words are long and some words are short, but that is a 16-bit word there. So the smallest binary digit is a 0 or 1. It's called a bit. If you put 8 bits together, you get a byte. And a 16-bit word has 2 bytes. So here's the first byte, here's the second byte. There can be 64, 32, and bit words depending on the type of CPU and computer system. So here we got 8 and 8 and 8 and 8. That's 32 in my book. 32 ones and zeros is called a double word. Okay, so that is a little bit smarter than a single word, I guess, if you want to think about it. Now, just recently, we're going to talk about how these devices communicate. The President of the United States met with the President of Russia, and I was wondering, I had to Google this, does the President of the United States speak Russian? And I wondered if the President of Russia speaks English. Well, they don't really speak that very well. And so what they had to do is they had to use a translator, all right? And so I want you to think of a bus as a translator, okay? And so whether you have human talking to machine, human talking to human, machine talking to machine, they're going to have to process the language of each machine or each device a little bit. And a bus will do that, okay? Because information cannot be lost during translation. So for example, I'm going to go to what's called RSLinks here. This is a proprietary software for getting devices to talk, Allen Bradley devices, all right? And so what I'm going to do is I'm going to slide this over here, and I'm going to pull this up right here. And so what I've got here going is I've got a cable right here, okay? I've got this cable right here, and over here, you're going to see I don't have showing any devices. So I'm just going to take this right here, and I'll just plug it into this one right here. How about that? Okay? This gets plugged into here, USB, and you hear it connect, boop, and all of a sudden up there, I've got a USB. It recognized it. If I expand these out here, give it a second, there it is right there. It found this rack here with this back plane. We'll look at 1, 2, 3, all these devices in here. That's what all these individual cards are here, okay? So somehow, my computer, which is this software over here, is talking to this computer over here, and it's talking using a USB A to B cable. And it was nice. It was just plug and play. And all of a sudden, boom, we're in business. We're talking. And just to remind you, my computer is connected to the internet, and I can now share this information if I wanted to with quite a few other people. All right. So as we keep going here, I want to talk about a little bit more about a bus. What is a communications bus? So a bus is a communication system that transfers data between components inside a computer or between computers. So it's like the translator. And it's what we're talking about: hardware, software, and communication protocols. Note that originally a bus also included power. And so what I got here is, you're going to see a lot of buses out there that you're going to have to configure and get working, okay? And so what I've got right here, if I make this large again, I've got a sensor right here. This is a this item right here is a 3D magnetic sensor array. It's very cool. But the issue with it is it's got a 9-pin RS-232, a DB9 port right here. Well, that is not an Ethernet port. I cannot just plug this into here, even though I would want to. So this is going to push out information, ones and zeros, I guess you want to think about it, and I need to convert it. So what I would do is I would use a bus. Here's a Siemens bus right here, okay? And so what this Siemens bus is, you would plug the wires from that into here, and look right there, it's got an Ethernet port. So then I would just run this Ethernet port into this machine, and then all of a sudden it converts that signal, that DB9 RS-232, and then my sensor array comes into my PLC. I can see it into my software, and I can share it using the Internet of Things. Okay, so that's kind of what a bus is. You're going to see a lot of buses out there. RS-232 standard, I've said it a few times. So this was an early standard that was established so that dissimilar machines could communicate or talk to one another. Because people were coming up with a computer or a system or a robot, and they wanted it to talk to another computer or system or robot. Well, they had to get together because everybody wanted to do it a little bit differently. So they came up with a standard of how things should communicate. And they talked about common voltages and common pin wirings and cabling and what kind of information to share. And so nowadays, if you buy a computer, and it looks like a printer here, and you bought this cable, this looks like it's got a DB9 cable, and you plug it in your computer and you plug it into the printer, they would work. They would recognize each other. They would talk. They would be translating between them and sharing ones and zeros, and it would work, all right? And so when items talk like that, you need standards in order to do that. Let's just talk a little bit about serial communications. So the telegraph or Morse code is an example of serial communications. Here's the Morse code person would be sitting around waiting for something to happen and be kind of a boring day. Then all of a sudden, you get this click, 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 and his tapper would get excited. And that means a message is coming. And then you would get either short dots or long dashes. And what these were corresponding to would be an R would be a dot dash dat. So we change that into binary, where 1 is a dot and a long 111 is a dash. Okay, and so that is sending one click or dot or dash at a time. Okay, what's this look like in electronically? Well, electronically, we're going to have an 8-bit signal, and here's our start bit right here. So once again, you think about sitting around waiting for the message, and here comes the message, and the message is 101101, and that is based on the voltages that you're getting. And then all of a sudden you get a stop, and then that is your message that came through, and you're going to get a lot of these bytes sent across very rapidly, and the computer knows what to do with them. Okay, so that is how it's passed electronically, one bit at a time, ones or zeros. All right. Now, transmission control protocol, TCP/IP, is what we use now. RS-232 is certainly still out there, but now we're using TCP/IP for Industry 4.0. It's a communication standard, and it provides asynchronous, which is intermittent transmission of data. It's not always transmitting, only when it needs to, just like the telegraph. Serial communications. It has a start and a stop. It has error checking. And we have 8-bit transmission in the data stream. They're a little bit different the way that does it, but basically that's how it's talking, with the ones and the zeros. So I got an RS links demonstration here. It says, what I do is I have my RS links up here again, and I've hooked up my Ethernet IP. I said that this was connected into the computer, and if I open this up and check my backplane, I indeed am also plugged into my PLC here using my Ethernet. So my Ethernet is talking to the Ethernet on that item, as well as my USB on my computer is talking to the USB on that. Both are different protocols, but due to the standards and due to the bus nature of the devices here, everybody can talk, and everybody's happy, and they can share information. They can share ones and zeros with each other. And setting this up is very critical for PLCs. Okay, and so just to recap, we have initially we started with a serial interface, RS-232. Format was asynchronous, a couple of devices not very far apart, and it was slow, but it worked. Okay, but things got more complicated in automation, and so they had to come up with different standards where we have more drivers and more devices and a farther distance and a much faster speed. And things kept progressing. You know how computers progressed over time. RS-485, we have more devices, still pretty long, speed's getting faster. We talked about USB, it's getting fewer devices, but its speed is very fast. Okay, and then now Industry 4.0 uses Ethernet, which is a fair amount of devices, pretty far, and super fast speeds, and that is what is going on right now. So to recap, originally, automation devices connected to computers and other devices using RS-232 COM-to-COM, but things changed. We needed more, so we went to do different standards that use proprietary equipment and bus technology. Bus technology is needed so that you can get all these devices talking. But nowadays, a lot of devices can connect just using A to B. There's no bus technology. The standard is set up. It's not as proprietary. And certainly the Ethernet is the way to go these days because it's not proprietary. You can just plug the Ethernet in, and a lot of these items recognize each other and they communicate. One final note. In addition to your education, you're likely going to need specific training on vendor-specific equipment in order to implement Industry 4.0 technology and the best practice. There's a lot out there, just a little idiosyncrasies. And then so we would have a lab that lists, that utilizes the RS links to connect up to a variety of different controllers and devices and establish communications to see how they work.